Right now, somewhere in this city, a cable thinner than your wrist is holding up a steel box full of strangers, 40 floors above concrete. And you step into that box every single day without a second thought. Here's the part that should terrify you. Elevators have no brakes on the way down, not in the way you think. If every single cable snapped at once, the thing that saves your life isn't a brake pedal. It's a 170-year-old trick so simple a child could understand it, and so reliable it's never once failed in a real accident. In this video, we're taking apart the machine you trust with your life more than your car, including the single 1852 invention that made skyscrapers possible. The counterweight trick that means your elevator is barely lifting any weight at all, and the reason the close door button in most elevators is a complete and total lie. The national elevator industry reports elevators make over 18 billion passenger trips a year in the US alone, and you are statistically more likely to be killed by your own furniture falling on you than by an elevator. This isn't luck, it's a century and a half of ruthless engineering. Let's get into it. Before 1852, buildings physically could not go past 6 floors, not because of materials, because of trust. Hoists had existed for centuries, ropes and pulleys hauling grain up warehouses. But everyone knew the truth. Ropes fray, and eventually, they snap. No one would ride a box up 10 stories on a fraying rope, so buildings stayed short and cities spread sideways instead of up. Then, in 1852, an inventor named Elisha Otis did something almost theatrical. He built a platform, hauled it up in front of a crowd at the New York World's Fair, and had an assistant cut the only rope holding it up with an axe. The crowd gasped, waiting for him to fall. He dropped about an inch and stopped. Otis hadn't invented the elevator. He'd invented the safety brake, a spring-loaded mechanism that, the instant tension on the rope disappears, jams metal teeth into the guide rails on either side. No rope, no fall. That one demonstration is the entire reason skyscrapers exist. Every elevator you've ever ridden still uses a descendant of that exact mechanism today. But a safety brake only explains why elevators don't fall. It doesn't explain how they lift a 2-ton steel box using a motor smaller than the one in your car. Here's a question that sounds stupid until you actually think about it. How does a relatively small motor lift several tons of steel, cable, and passengers dozens of times a day without burning out? The answer is sitting right behind the walls of the elevator shaft, and you've never seen it. It's called a counterweight. A block of steel roughly equal to the elevator car plus about 40% of its maximum passenger load, hanging on the opposite end of the same cable, running over a pulley at the top. Think of an old-fashioned well bucket system or 2 kids on a seesaw. When the elevator goes up, the counterweight comes down. The motor isn't lifting the full weight of the car, it's really only overcoming the difference between the 2 sides, plus friction. That's why elevator motors can be so deceptively small. They're not brute forcing tons of steel skyward. They're nudging a near perfectly balanced system that wants to move anyway. It's the same reason it feels almost effortless when the doors close and you barely feel the motor engage, because structurally it barely has to. But balance and brakes only get you moving safely. They don't explain the part everyone secretly hates, the weight and that door button you've been lied to about. Quick test. Next time you're in an elevator, hit close door and time how long it actually takes to react. In most modern buildings, the answer is, it doesn't react at all. In 2016, The New Yorker investigated this exact phenomenon and found that in the vast majority of US elevators installed after the early 1990s, the door close button is deliberately wired to do nothing. It's a placebo button, required by the Americans with Disabilities Act to exist so that maintenance workers and firefighters can use it with a key override, but disconnected from public use so people can't trap someone rushing toward the doors. So why do doors still close faster sometimes? That's not the button. That's the elevator's control system, deciding based on traffic patterns, time of day, and how long the doors have already been open. You're not controlling the elevator, you're performing a ritual for a machine that already made its decision. And you're not the only one who does it. That's just how deeply we trust the illusion of control. Now, everything so far makes elevators sound almost too well designed to fail. But there's a version of this system that engineers had to build specifically for the worst case scenario, the one time in a billion when everything actually does go wrong. Here's a twist almost nobody knows. If you're ever in a genuine freefall scenario, which, again, has essentially never happened due to the safety brake system, the worst thing you could do is what every disaster movie tells you to do. Jumping right before impact doesn't help. You cannot time a jump against a falling car accurately enough for it to matter. And doing so removes your body's best shock absorber, staying flat, distributing impact across your entire body, protecting your spine and skull specifically. But here's the deeper, stranger truth. Modern elevator shafts are partially cushioned by the same physics that make this scenario nearly impossible in the first place. As a car falls, it compresses the air beneath it in the sealed shaft, creating an air cushioning effect that measurably slows deceleration force. Combined with governor-triggered safety brakes that engage automatically at abnormal speeds, and as an absolute last resort, a shock-absorbing buffer at the pit of the shaft, elevators are layered with 5 independent failsafes stacked on top of each other. Not 1, 5. That's the real twist. The machine feels like blind trust, but it's actually one of the most over-engineered, redundantly protected systems you interact with in daily life. More regulated and more frequently inspected than most cars. And specifically because engineers assumed, from Otis's first demonstration onward, that everything eventually fails, and built 4 backup systems for the one time it does. So next time you step into an elevator, here's the one thing to actually notice. Look at the panel above the door showing the inspection certificate. That date isn't decoration, it's proof that this exact stack of 5 redundant failsafes was tested within the last year. By law, specifically so you never have to think about any of this. But elevators aren't the only everyday machine engineered around a catastrophic worst-case scenario most people never think about. Your car has one too, hidden in a system most drivers have literally never tested on purpose. Click on this video and I'll show you why your brakes are designed to fail in a very specific, very deliberate way,